All right, we have number 20 for our ACT math prep. This is the no calculator section. So with problem 20, remember, we don't have multiple choice here. We have a write in your answer. So because we have write in your answer, it's super important to remember you don't need a calculator for this problem. You can do it without one. Sometimes it's even better to do it without one. So let's look at our information given. We have x squared plus bx plus c equals 0, okay? In the given equation, b and c are constants. So that means there's some number that's known, it doesn't change, it is constant, right? So for example, you could have, and I'm not saying this is this, but for example, we could have x squared plus 4x plus 12, right? We could have something like that, okay? And that equals 0. So in the given equation, b and c are constants, if negative b plus the square root of b squared minus 4c equals 18, and negative b minus b squared, the square root of b squared minus 4c equals 10, what is one possible value of x? All right, now this looks super complicated, right? But we know that anytime we see a polynomial like this is a trinomial, right? There's 3 individual terms, so it's called a trinomial. We can factor that into 2 binomials, right? The question's asking us what is one possible value for x. So we know this is going to equal something of this form that equals 0. And then we can set each one of these equal to 0, and then we can solve for x, right? Now, how do we factor something like this? Because we know b and c are constants, we know it's something in both of these. Those 2 numbers will multiply together to get to c, and they will add together to get to b. But we don't know what b and c are, so we can't use our normal factoring trick. So you guys should have seen this before. This is another one of those problems you just kind of have to recognize. Because it's so complicated, this looks so messy, right? You guys have to know something, probably a formula or something off the top of your head. So this particular formula that you should recognize from this is the quadratic formula. The quadratic formula allows us to factor without having some multiple of c and some that adds to b. So it's negative b, and b is going to be this value, c, this coefficient, c is going to be this constant. There's also an a in here, which is going to be x. But we know that a equals 1 because there is no a, right? There's no a because anything times 1 is itself. So we know there's like a 1x squared here, right? So a equals 1. So our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Now, do you notice some things between this quadratic formula and the left and right side here? So because it's plus or minus, if you haven't seen plus or minus before, let's say we have x plus or minus 2. Or let's say, instead of x, let's say we have like 5 plus or minus 2. That means that we have 5 plus 2 and 5 minus 2, which means we have 7 and 3. Okay. So if we have negative b plus or minus all of this, that means we have negative b plus the square root of b squared minus 4ac, and we have all over 2a. And we have negative b minus the square root of b squared minus 4ac all over 2a, okay? This numerator looks strikingly similar, right? The only thing that's different is there's some a's in here and there's a 2 on the bottom, a 2a on the bottom, and there's some a's in here. But remember, a equals 1, right? So we can go one step further. Because a equals 1, we can substitute 1 for a. 2 times 1 is just 2. Anything else times 1 is just itself, right? So we have negative b plus the square root of b squared, no a's there, minus 4ac, 4 times 1 times c, so just minus 4c, all over 2 times a, which is 1, so 2 times 1 equals 2. Same thing over here. We have negative b minus b squared minus 4c. So just the same except for this plus or minus sign, because it's plus or minus, right? All over 2 times 1 is 2. Okay, now the numerators are exactly the same. So we can substitute. Again, we know that it's 18 and 10. So just like we have like x equals 18 or a equals 1, and we substitute that in, we can substitute this entire part for 18. And substitute this entire part for 10. Do you see those are equal? This whole part here is like this part down here. And this whole part here is this part here. So because we can substitute the entire part for each one of those numbers, 18 and 10, let's do that. So we have this entire part is 18, so we have 18 on top and 2 on the bottom. And for this right side, we have 10 on top and 2 on the bottom. 18 over 2 is 9, 10 over 2 is 5. And now we have two numbers. After all of that messy math up there, that does actually look very satisfying when you look at it. Math is really beautiful. Like, look at this. This is great. So I should keep working it. I bet your math teacher would appreciate that too, right? So we have 9 and 5. So what do those values mean? Well, the quadratic formula, it just gives us x. That negative b plus or minus square root of b squared minus 4ac all over 2a, that's what x equals. So now that we know that, we've recognized it, we've found the values, we know x equals 9 or 5, right? It actually equals 9 and 5. Excuse me. And is a better word there. 9 and 5. We have two values for x. So then, how do we do this problem? We recognized that the quadratic formula, specifically the top, looks very similar to both of these here. So we looked at it, I looked at it, this is what you guys should be doing. You should look at the problem, see what do I know that correlates with something that the problem's giving me. And then how do I manipulate, because this isn't exactly the quadratic formula, right? There's a 2a on the bottom. We had to recognize there's a 1 in front, that's the a, so we have to divide by 2 at the end, right? So if you recognize that, even without doing all this work, notice you could just divide this 18 and the 10 by 2 and get your same answers of 9 and 5. This is the work to show you how that works. But if you know your stuff and you know your formulas, how they work, how to manipulate them, you know your mathematical principles, your laws like the commutative law, the distributive law, how to put things in terms of variables, you could look at this question and go, ha, gotcha. X equals 9. What is one possible value? X equals 9. So the two possible answers for this problem, having said that, we have x equals 9, that'd be perfectly fine. We have x equals 5. It wants one specific value. Anytime it's asking you for one value, don't give two. Just give one. They will mark you right for either one of them. Don't put both of them though, because they might not mark you correct for certain problems, because they're specifically asking for one. And then if you put like 9, and then on this side you made a mistake and you got like 4 or something, make sure they might mark you wrong because you did the problem wrong, right? Because this wouldn't be x equals 4. So don't risk it, just do one correct answer, right? So again, looking at this problem, think of, or any word problem, math problem, make sure you look at it, see what can I use, what do I know, and then practice good mathematical principles, and they'll lead you to the answer. Think about how can I manipulate what I do know, the equation, in order to help me solve it. Answer is 9 or 5.